introduce Balluff as a company. Balluff is a fourth-generation family-owned business with a history that goes back more than 100 years. Since 1921, innovation and customer focus have been at the heart of everything we do. Today, we employ about 3,900 people worldwide, and we are proud to serve more than 30,000 customers and partners across the globe. Our footprint includes 38 subsidiaries and representation in over 60 countries, supported by 7 production sites worldwide. This global presence ensures that wherever our customers are, we are close by to support them. And when we talk about our portfolio, it is comprehensive from sensors and identification systems to image processing, networking technology, and software. So we provide end-to-end solution for the industrial automations. So the Balluff journey began over a century ago in 1921 when Gebhard Balluff founded the company as a mechanical repair workshop. Today, Balluff stands as a trusted automation partner worldwide, built on this legacy of innovation and customer focus. So at Balluff, our vision is simple yet powerful. So with our passion for industrial automation, we lead our customers to a successful future. At Balluff, our mission is clear. With innovative solution, we improve the competitive position of our customers with speed and results. So with 38 subsidiaries for sales, production, logistics, and development, with further representatives in 68 countries. So let us have a presence in APAC. So we started with the Japan and Australia, Singapore, South Korea, and at last by the India. So next we have a presence in India. So we have a head office in Pune and warehouse in Mumbai, and we have other area sales presence in Delhi, Ahmedabad, Nagpur, Kolkata, Bangalore, Chennai in South. So let us have a video short clip about our Balluff journey. So let us have our market segments. So we have automation expertise in many industries like automotive, battery, tire, semiconductor, electronics, metalworking, assembly, life science, plastic and rubber, packaging, metallurgy, and so on. So our portfolio, we have sensors, industrial networking, RFIDs, HMIs, machine vision and optical identification, power supplies, connectivity, accessories, software, and system solutions. So at Balluff, we don't just deliver products, we deliver complete solution and long-term support. Our services are designed to ensure customers get the maximum value from their automation investments. First, through agile project management, we make sure projects are executed quickly, flexibly, and with minimal disruption. Second, we provide customized solutions tailored to the unique needs of each customer and application. Third, our 24/7 account management ensures that customers always have a dedicated partner available whenever they need assistance. And finally, we back it all with technical assistance, giving our customers confidence that their systems will always run smoothly. Together, these services reflect our commitment to building strong partnerships, supporting customers not just during implementation, but throughout the entire journey with us. So now let's dive into the heart of today's session, 3D Vision. Balluff offers smart 3D cameras that come with onboard processing. This means they don't just capture images, they actually process and interpret the data directly inside the camera. So it reducing the need for extra hardware. So they are designed for easy operation with a user-friendly web-based interface. So setup and configuration are quick and straightforward. Flexibility is another strength. So with the Gigi Vision interface, our cameras integrate seamlessly into existing automation systems. What makes this camera powerful is the ability to run application-specific software modules, so enabling them to adapt to a wide variety of industrial tasks. And finally, with the stereo cameras offering 12 megapixel resolution, even the most demanding application can achieve precise, reliable results with this. So here we can see some of the technical specification of Smart Balluff's 3D cameras. So they are available with different base distance 65 mm and 160 mm to cover various applications. The lenses comes with the focal length of 4 mm or 6 mm depending on the required field of view. In terms of resolution, the camera capture at 1280 by 960 pixels, giving us over 1.2 megapixels per image. The field of view ranges from 61 cross 48 degree for wider coverage to 43 cross 33 degree for more focused applications. The depth measurement ranges goes from as close as 20 centimeters all the way up to 3 meters. So with depth resolution as a precise of 0.04 millimeters in certain configurations, that's sub-millimetric accuracy. So, and importantly, these cameras are available in both monochrome and color versions. So customers can select the option that best suits their application. Here you can see the field of view of our 3D camera modules. On the left, the BBS003Y, BBS0047 models designed for shorter working distance at around 200 to 500 millimeter range. They can capture small areas with high detail, making them ideal for close range inspection or precise robotic guidance. In the middle, the BBS004K, BBS004Y models, these provide a balanced field of view, covering both mid-range and large areas up to 3 meters. They are great for general purpose applications where flexibility is important. And on the right, the BBS0057 model, this camera is suited for a wide working areas, capturing larger objects or bins. It allows detection across 2 to 3 meters, which is especially useful in logistics, warehouse automation, or palletizing tasks. So depending upon the application, where it's close-up precision or wide area detection, Balluff offers the right camera with the right field of view. So here we see our stereo camera options. So with 12 mm lenses, ideal for wide coverage and shorter working distance. With 16 mm lenses, a balanced setup for mid-range applications. And with 25 mm lenses, for focused long distance precision. Each version is applicable in both monochrome and color. So customers can choose what best suit their application. So next, this diagram shows how the field of view expands as the working distance increases. At 500 mm, the camera covers about 320 mm width, and 1000 mm it expands to around 620 mm, and at 2000 mm the coverage grows to over 1.5 meters, and 4000 mm nearly 3.3 meters wide. This flexibility means the same camera can be used for both close-up precision and large area detection, simply by adjusting the working distance. So next, this table shows how different camera models and lens options impact the field of view, results and depth accuracy. Our 1.2 cameras with 65 mm, 160 mm baselines are suited for standard application, balancing field of view and resolution. The 12MP 3D RV1 camera with higher pixel density and longer baseline delivers exceptional precision with depth accuracy as fine as 1 millimeter, even at longer working distance. In simple terms, the calculator helps match the right camera setup to the application's accuracy and coverage needs. Next, our smart 3D camera runs on a supply voltage between 18 to 30 volts with 24 volts nominal. The power consumption is low at just 25 watts and the system includes overcurrent protection. Fuse limited to 2 amps for safety purposes. For connectivity, we use an M12 8-pin plug connector. This pinout handles both power and GPIO signals, including triggers and output for synchronization. So next we have the platform here, so 3D cameras and accessories, and we have a dot projector cable available in 5 meter or 10 meter, and we have a calibration board here and software modules. So we have a software modules for fruit picking and checking the tag detection and so on. We'll discuss these software modules in the upcoming videos. So software, RoboSubscription offers the open source tool RC Discover GUI, which can be downloaded free of charge from our website for Windows and Linux. All startups are available with our Gigi Vision devices, including RC Wizard device, are listed with their names, serial numbers, IP address, and unique MAC address. The Discovery tool finds all these devices reachable by global broadcast, like as below. Next, we see our web GUI page. Here we can find camera settings, depth image, dynamics, modules, configuration, database, and system. So we look into camera calibration. The quality of camera calibration heavily depends on the quality of calibration grid. So calibration grid can be purchased from Balluff. So the size of the calibration grid will be mentioned at the bottom of the grid as you seen in the picture. So the typical calibration error is below 0.2 pixels. If the error is in the range, then the calibration procedure can be skipped. If the calibration error is greater, the calibration procedure should be performed to guarantee full sensor performances. So here we have a stereo calibration. During stereo calibration, both cameras calibrated to each other to find the relative rotation and translation. So next we have a grid must be kept very still for the detection. If motion blur occurs, the grid will not be detected. So all the grid cells that are drawn into the image have to be covered by the calibration grid. So this is visualized by filling the covered cells in the green as you see in the picture. So next we have a small video about calibration techniques. So let us have a video. So in this we have a calibration grid option, large grid 0.39 cross 0.27 meter range. So we'll click on the next. We can see the grid in the background. So it is highlighted with the green highlights. So here the recalibration should be recommended because the correction range is 0.15 to 0.5 pixel. So current error is 0.15 pixel error. So we need to adjust and we should calibrate both cameras to each other. So we have to hold the grid as close as possible and kept it still. If necessary, we have to repeat different positions until it visualizes cells. So now the process is carried on. So you can see the grid in the background. So it is adjusted to cover all the green highlighted. So you can adjust the camera so that left and right can cover both. So we have to keep the grid as far as possible to cover the entire grids. So now we move the grid as much as far. So we can check the exposure, auto exposure range, time, everything will be perfect. So we now further move backward. Now we can see that it is overexposed so that we can adjust the exposure to sit in the right position. So we'll adjust the camera. So now it covered the entire grid. So now we have an option, compute calibration. So the calibration is done and you can save. So calibration finished, press save to apply. So the value is between the range. The calibration finished and parameters are stored. It will completely save. And the calibration is saved permanently. We don't need to carry again. Yes. So now mono calibration. So mono calibration should only be performed if the result of stereo calibration is not satisfactory. So stereo data processing results. So now let us take a look at the result of stereo data processing. What you see here in the transformation from a basic 2D image to a fully reconstructed 3D model, all enabled through advanced stereo vision technology. Starting on the left, we have the 2D camera image which captures a standard grayscale visual of the object in the bin. Next, in the depth image, this provides a color-coded map indicating how far each point is from the camera. Notice the gradient from blue to red, representing near to far objects. Then we have the confidence image. So this tells us how reliable each depth measurements is. Brighter areas means the higher confidence. This is crucial for downstream applications that rely on precision. Finally, the 3D reconstruction with sub-millimetric accuracy, we are able to generate a highly detailed and accurate 3D model, which is essential for tasks like bin picking, inspection, and robotic automation. Now, next let us explore how we go beyond basic imaging. What you are seeing here is not just a stereo camera, it is integrated system that combines image acquisition with onboard pre-processing. At the core is the NVIDIA Tegra K1, enabling powerful edge computing. The system also supports point cloud generation, visual inertial navigation, SLAM for real-time localization and compatibility with GenICam and GigaVision standards. The stereo cameras does not just capture image, it extracts depth, motion and position information all in real time. On the right side, we see application-specific tools in action, from fruit sorting and bin picking to inspection quality control. These solutions are already being deployed in industries like agriculture, logistics, and manufacturing. Next, we have USB and benefits. USB, it is onboard GPU enhanced processing. Since it is equipped with NVIDIA Tegra K1 computing unit, the camera not only calculates depth information, but also more relevant information like pick points for robots. And it reducing the system cost by using onboard processing without the need of an external PC. If an external PC is used anyway, processing power can be saved, since the camera does the depth calculation onboard itself. Next, the reducing the integration cost. The camera is easy to integrate in existing machinery in a timely manner. Only a minimum of modification is needed for integration. The initiative web interface and software tool additionally reduce the integration cost. So before we wrap up, here is a quick reminder. You can easily explore and purchase Balluff products online. Just sign up at the link shown on your screen. So we have saved time with online shopping using our My Balluff website. So stay connected with our LinkedIn and blogs and everything. So thank you all. Have a nice day.